Okay, so in this video we're going to investigate what happens when you do the transformation f of minus x. Now this is not to be confused with minus f of x. When it is outside, we saw it did this kind of vertical flipping over. This time it is inside, so we're changing the input rather than the final output that we've got here. So again, from the first video I described about this function that we've got here, the original function, we're now going to change the inputs. So instead of putting in x, we're going to put in minus x. Now what this means is, instead of putting in minus 3 into this function, we're actually going to be putting in 3, because we've already said don't put x in, put in minus x, and minus 3 is positive 3. Now when you put 3 in the function, our original graph tells us that when you put 3 in the function, you get 0. And I'm not going to put minus 2 into the function, I'm going to put 2 into the function, because when I negate minus 2, I get 2. And when you put 2 in the function, you get minus 2. Now similarly, you're going to see this pattern. I'm not going to be putting in minus 1, I'll put in 1, which also gives me minus 2. When you put 0 in, you're going to get the exact same point, because the negation of 0 is just 0. This time I'm not going to be putting in 1, I'm going to be putting in minus 1. And when I put in minus 1, I get the output of 1. I'm going to be putting in minus 2, which gives me 3, and at the end I'm going to be putting in minus 3 instead of 3, and that will give me the output of 1. Now I'm wondering if you can predict what it's going to look like when you take this and put it on the graph. Hopefully what you're seeing here is that this set of numbers is the same as this set of numbers, but it has kind of like flipped in a left and right direction. So that might give you a clue about what this is going to look like on the graph. So I'm going to take these pairs of coordinates, I'm talking about like the minus 3 and the 0, the minus 2 and the minus 2, and we'll see what happens. So the minus 3 and the 0 will be this point here. Minus 2 goes with minus 2, minus 1 goes with minus 2, 0 goes with 1, that was the one that didn't change at all, 1 goes with 1, 2 goes with 3, and 3 goes with 1. So all that's left to do now is to join these points together. So joining these up, if I could only do it more neatly, that's better. Now this isn't the easiest kind of thing to spot, but what I'm hoping that you've seen is this kind of like original mountain sort of spike we had here is now flipped and on the other side, and this kind of like valley shape that we've got here is flipped and now on the other side. So it has either been described in kind of two different ways. It's either you can sort of think of it as like a horizontal kind of flip over, or you could think about it as a reflection in that line, the y-axis. So it's either a horizontal flip, so we can either say that it is a horizontal flip, like in this kind of direction, everything on the right has gone to the left, everything on the left has gone to the right, or we could say that it is a reflection in the y-axis. So this blue graph is reflected in that line that we've got there. So let's think about what that actually does to the coordinates. Well, the y-coordinates have stayed the same, the x-coordinates have just negated. So previously where we had minus 3, 1, minus 3, 1 was over here. That coordinate has now moved all the way over to here, which is 3, 1. So the x-coordinate is the one that has negated this time. This one is just going to become minus 1, minus 2, just the x-coordinate is negating, and then we have minus x and y. So let's just have a quick investigation about how this is different to the one that we did here. In this one, just the y-coordinates were negating because it was outside the entire function. It's like saying just take the y-coordinate and negate it. In this one, the x-coordinates were the ones that were negating because it was inside the function's input, and the input is to do with x. So what would this look like algebraically? What would it look like if we had these different functions here? Well, it's kind of similar to the previous video in where I'm not going to just negate the outside, I'm actually negating the input that we've got. So instead of it being sine of x, it is going to be the sine of minus x instead. And again, I'm now going to be thinking about what this would look like. I'm going to change each input. Anytime there is an x, I need to make sure that it has a minus with it. So it's going to be a minus x squared plus 2 multiplied by minus x plus 3. Well, negative x times negative x is a positive x squared. Positive 2 times negative x is negative 2x, and we have plus 3. So this one's quite weird. You wouldn't necessarily tell by looking at this and this that just the input has switched from an x to a minus x and it would represent this reflection, but it does reflect that, it does represent that. So this is, I'll quickly just show it to you on Desmos as well. So let's just switch this one off here. We're going to be switching this one on, and you will see the red graph is the blue one, but it's reflected in the y-axis. Okay, it's reflected in the y-axis. So there's a bit of a summary that we've got here. Here are the 4 transformations that you need to know about. Okay, you need to know that if you have this plus a on the outside, it is a translation exactly how you'd expect. In the y direction, it is just moving a spaces upwards. If it's also on the outside, you will have that it is either a reflection in the x-axis or it is a vertical kind of flipping. So I think that when something is on the outside, either this plus a or this minus, it's to do with things that are vertical or moving up and down. This one, where we have this translation, it does kind of the opposite of what you'd expect. This is the weird one that you need to pay attention to. I'm going to put a little star next to it. It is moving a spaces in the opposite direction. Normally when we think of positive things, they move to the right. This time, if it was a positive a, it would be moving to the left, which is represented by this negative here. And the last one, if you have this minus inside for the f of x, it is a reflection in the y-axis, or it is a horizontal flip. So if it's inside the brackets, it's things that are in the kind of left and right sort of direction. It's like a flipping in the left and right direction. So that's kind of the theory of these 4 different transformations that we've got here. And what we're going to do is we're going to apply these in some questions to think about how we might be able to use them. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.